Today is 25th of October 2023, and this will be our fourth lesson on bearing, and we are going to look at some type of examples on bearing. Thank you to everyone who has been here helping on our channel by subscribing, sharing, liking, and following us, and also watching as well. Okay, don't just do this. Watch. If you have an exam next year or next 2 years, watch. Make sure you understand it, and then make sure you can solve the questions so that you can be successful. Okay, and if the account is not yours, please ask permission. Okay, if you are below the legal age, maybe you are in year 6 and you are very smart, and you can't have an account, please ask your parents' permission if you are using the account, or they can help you open an account. Okay, so please take note of that. Don't just use somebody else to subscribe. Let them know before you do that. I normally write, please follow my notes /scripts in the comment section. Okay, we all know this is math. At times, there is a lot of numbers and stuff. So, assuming I'm saying 147, and I say 17 or 14 or 47, or interchange degrees for percentage, please just follow the notes. Okay, if you follow, these are notes I made myself, and as I'm presenting, if there is something not right, I would correct it as we go along, so the note is your accurate thing. So watch, listen, follow the notes, see how I explain it, how I solve it, and use it to help yourself. Okay, if it's to scale, I'll tell you. If it's not to scale, I'll tell you. If I'm measuring and I can't get the measurement on phone, you can go and try it yourself. Okay, because most of the time I measured it before I came online. Please beware of scammers. Okay, beware of scammers. Don't give money to people who are bothering you online. I haven't asked for donation, please, for any orphanage or charity or ill people or whatever they are saying out there. So be careful, beware of these people's scammers. Now, recap. We looked at more bearing examples, okay, because bearing or bearings are questions you can easily take full marks on, but at times people ignore it, maybe because of the wording or because they didn't learn it. But I'm trying to show you how you can get marks as you solve your questions. Okay, so that's why I keep on bringing all these examples. and we explained that bearing from point A to T will be different from T to S. So you need to understand the question and what you are being asked to do. Okay, it's very important. So the bearing of a point S to T will be different from the bearing of T to S. So if they give you the diagram, or you are being asked to draw the diagram, you need to see what they are, understand what they are asking to do. If you can do that, you can get the full marks. Okay. Now, please refer to the last video. It will help you a lot. Okay. Our starter today will be a bearing example. Okay. What is the bearing of T from S? Okay. So we want the bearing of T, but this is the point we want the bearing from. Okay. So now we've been told this is 0.72 degrees. So using supplementary angles, this will be 180 degrees. We've done parallel lines, we've done C angles, we've done F angles, we've done Z angles. So go and have a look if you don't understand. Okay. Now, if this is this angle 72, add this angle will be equal to 180. So this is why this is 108 degrees. Okay. Remember, it's bearing, so we write our angles in 3 figures. So now the bearing of S from T, so from T, okay, if this is 180, from the north clockwise all the way around, we need this angle, and then we travel down and we get to T. So if we subtract 360 from 108 accurately, we get 252 degrees. So that's why this is 252 degrees. Okay. What is the bearing of S from T? So the bearing of S from T, now this is T, this is our north. So from T, this is 72 degrees. Okay, and then we travel to S. So our angle here is 0.72 degrees. So that is our bearing here. 0.72 degrees. We measured clockwise from the north, and it's in 3 figures. Now today we want to look at more bearing examples. Okay. Again, what is the bearing of T from S? So here, T, S. Okay. What is the bearing of T? This T here. This T here from S. Okay, so that's the straight line north. So this angle here is 10 degrees. So we need to go all the way around, and then we travel to T. So it will be 350 degrees. So that is our 350. I draw this angle to scale, and I measured them. Okay, so these angles are to scale. What is the bearing of S from T? So from T, okay, so now this is T. Okay, if this is 10 degrees, by supplementary angles, that will be 170. Okay, so from T 170 we travel to S. So the bearing of S from T is 170. So again, we used supplementary angles or C angles, and then angle at the point equals 360. Remember, we can only use supplementary angles, C angles, when they are two parallel lines. These straight lines, okay, and the arrow tells us that they are parallel lines. Okay, now let's look at another diagram. So let's look at the diagram here. This is the diagram we have. Okay, this is the diagram. What is the bearing of S from T? Okay, so now from here, two parallel lines. Now we have three parallel lines. So don't look at the question and say, oh, I have just been given, I only know the two parallel lines. So these are three parallel lines and I don't know what to do. You know everything from angles and from bearings to help you solve this equation. So let's have a look. What is the bearing of S from T? So this is our T here. Okay, so this is the north. When you measure this accurately, it's 130. Okay, that is it. So 130 clockwise there, and then we travel to S. So here again, our answer is 130. Three figures we measured from the north and clockwise. Okay, what is the bearing of T from S? Okay, so now we want the bearing of T from S. Okay, so now this is our S, which is the reference point, that is the north. We have to measure clockwise, so from here to there. Now using supplementary angles, if this is 130, then this is 050 degrees because it's in bearing. So we need to put a figure in degrees in three figures. So from here, if this is 50, all the way round will be 310, because the whole angle here is 360. Okay, remember first quadrant, second quadrant, third quadrant, the fourth quadrant. So that's 310. Then we travel to T. So the answer will be 310 degrees. So that is our answer here. What is the bearing of T from R? Okay, so the bearing of T from R. Now this is R, that is the north. Okay, the angle from at R here, okay, this angle here is, and this line connects R to T. So if you measure this accurately using the protractor, you get 065 degrees. We measured clockwise and from the north, and it's three figures. Then we travel upward to T. So that is 065 degrees. So 065 degrees. Okay. Again, we applied supplementary angles or C angles and angle at the point. Okay. There. So this is what we've seen so far. So this one, we have three parallel lines. Okay. Now let's look at another example. So today we are just looking at examples, and we are trying to expand our knowledge on bearing, so that even if you get a complicated example, you'll be able to solve the question. Okay, so the last example we solved is this one. Look at the diagram. Okay, now here is another diagram. Okay, that one here. I hope you can see this. Okay, and that is R, T, and S. Okay, so they said consider the diagram. What is the bearing of S from T? Okay, now the bearing of S from T, okay, we have to measure it. So I did measure it. So from T, that is my north, and that is clockwise. So if I measure clockwise, this will be 0.55. Okay, and then I travel to the north. So my bearing of S from T, T is my reference point, will be 0.55 degrees, again in 3 figures. What is the bearing of T from S? Okay, so T from S. So this is the angle I need to be starting from, but I want the bearing of T from S. Now, if this is 0.55 degrees, using supplementary angles, if I take it from 180, this angle here will be 125. Now, this is the angle I want from this north clockwise to this line, so that I can travel to T. Okay, so if I take 125 degrees from 360 degrees, I'm going to get 235 degrees. Okay, I did it on the calculator and I measured. It is right. Okay, so my bearing of T from S, so from S all the way around there is 235. So that's why we have 235 here. Okay. What is the bearing of T from R? Okay, so the bearing of T here, okay, from R. Okay, now this is the north. Okay, that is the north. If you measure this angle accurately, it's 12 degrees. Okay, so this is R. You measure clockwise, and then this is the line that leads to R. So that will be 0.12 degrees. So here, 0.12 degrees. Okay. Again, supplementary angles or C angles and angle at the point. That is the knowledge we use. Now, let's see. Okay. Notes. So that is the diagram here. And that is what we've done here. Notes. You can be given the diagram to scale and asked to measure the bearing from the diagram. Okay, so even though all this I've done today, I measured it from scale. Okay, so for instance, this angle here, 12 degrees, I can quickly show you. Okay, so that one here, I'm going to turn it, okay, for you to see that is 12. Okay, so let me zoom in properly. So that is 12 degrees there. Okay, that's 12 degrees. So today I've measured all my angles. Okay, and I remeasure to be sure. Okay, so let's look at another example. Okay, now you can be given the diagram, okay, to scale and asked to measure the bearing from the diagram. Okay, so another type of bearing questions is you can be given a diagram, nothing. Okay, all these figures I did it myself, giving you the scale, and then they'll ask you to measure from the diagram. Okay, which is also easy marks to take. All you need is a ruler and a protractor. So here, the diagram scale in on the ruler is 1 centimeter to 100 kilometers. Okay, so even though you have 1 centimeter, in actuality it's 50 kilometers. That is what it means. Okay, what is the actual distance from R to T? So here you are. I did measure it. Okay, so I'm going to show you. Let's zoom in here. Okay, so it's about 5 centimeters. Okay, it's 5 centimeters. I did measure it exactly 5 centimeters. Now 5 centimeters, and you are being told 1 centimeter is 50 kilometers. Okay, so that means 5 centimeters will be 5 times 50. So that will be 250 kilometers. So the actual distance in real life from R to T, assuming is the distance between Nottingham and Lancaster. Okay, I'm just guessing, I don't know. Okay, so there, that will be 250. So even though you got 5 centimeters on the diagram, using the scale, it is 250 kilometers. Remember your units. If you write 250 centimeters, because of your units, they might mark you down or they might not give you the marks. So just be careful. Okay, it's 1 centimeter to 50 kilometers, not 1 centimeter to 50 centimeters. So be careful about the units. what is the actual distance from T to S? So you go to the diagram. This is your T, that is your S. Okay, when I measured, it was 5.5. But let's see. Okay, I wanted to get to this part so that I can take you through the measurements. Okay, so if we zoom in, that is 5 here. That is 5 and 5.5. Okay, so if 1 centimeter here is 50 kilometers, then 5.5 centimeters times 50 will give you the actual distance. Okay, and when you do it correctly on the calculator, you should get 275 kilometers. Okay, don't forget your units. Now the same question. Okay, they've given you the diagram, no measurement, all the things I've circled. Okay, I found them. I wasn't given. Okay, so measure. Immediately they say measure, you need your protractor, this one. So actually this question, you need a protractor and also you need a ruler. Okay, so here measure the bearing of T from R. So T from R. So you come on the diagram and look for T and for R. Okay, so I want the bearing of T, but from R. So this is the angle I want, because I have to measure from the north clockwise, get to this and travel all the way to T. Now let's look at the angle. So if you measure accurately, you get 0.77 degrees. But I'm going to show you because I did measure accurately. Okay. So here, I think I might have to change this angle because it's more than 77 degrees. But let's see. Okay, so from here, it's even the second quadrant. Okay, so if I look at this line here, that is 90 here. Okay, that is 100, 110 and 116 here. Okay, so this angle here, so what is the actual distance? What is the bearing of T from R? So if we do it again, let's do it again. If you do it again, sorry. What is the bearing of T from R? Okay, so if we do it this way, there, okay, I need your listen. So that's 90 here. Okay, that's 90. That's 100, 110. So that'll be 100 and about 17. So this angle here is 117 degrees, because if you when you think about it, it should be in the second quadrant, because 90 degrees will be like that. So this angle here, so it's 117 degrees. Okay, so this is not 77. Okay, that's why you have to measure accurately, and that's why I say you should follow my notes. Okay, now what is the bearing? So let's see the bearing. What is the bearing of T from R? Okay, so this is R, and then we travel north clockwise to there and travel to T here, and it's 117 degrees. What is the bearing, okay, of T from S? Okay, what is the, so from S here, okay, all the way around. Okay, so we want the bearing of T from S. Okay, so if this is 117 degrees, okay, then we need this angle here. So I'm going to just measure it. Okay, so again, if I measure this angle, let's have a look. Let's look at it. So if I measure the angle accurately, okay, so here we've been given the diagram and we have to measure. Okay, so you just write what you get. So that is where if you copy, you'll be caught. Okay, so if somebody wrote that and you also copied, you'll be caught. Okay, so this is 0 all the way. We want this line. Okay, let's zoom in and see what we get. So that is 100, 110, and it's about 105. Okay, now if this is 105, I wrote 112 because I think when I measured I got 112. The angle all the way around from the north, okay, is 360. So I'm going to take 112 from 360, and if I do it properly, I should get 248. So my bearing from T from S, so that is S. Okay, so I travel all the way around 248 and down there, so that is my bearing. Okay, my bearing of T from S, that one here. That is where we are now. Yes. So 248 from the north clockwise all the way down to T. And the last one, measure the bearing of S from T. Okay, so measuring the bearing from S. So this is T. Okay, you can see it's in the first quadrant. If you measure it accurately, that is 070. So you turn 070 degrees, travel all the way around to S. So that is 070 degrees. Now, because this is 117 degrees, okay, using supplementary angles, this will be changed. This will no longer be 103, so I'm going to cross it out. And if I take 180 from 117, I end up with 63 degrees. But it's three figures, so I'll end up with 063 degrees for this angle here. Okay. But we didn't need this angle. We needed this angle. We needed that angle here. And then we needed this angle here. Okay. So this is how bearing questions can be so easy. But because of measuring, you can easily make a mistake. Okay, because I did measure this, but even thinking about it, this would be in the second quadrant, so 077 degrees wouldn't have made sense anyway. Okay, but because I have that knowledge, I was able to correct it. Okay, so you remember when we did estimations? Okay, so with the knowledge you have, you can easily write an answer, and then as you go over your work, you can say to yourself, this doesn't make sense, and then you can quickly correct before you give your work out. Okay, thank you. So far with the bearing topic we've been looking at, we've used some of the angle knowledge that we have. Apart from in bearing, we write our angles in three figures. Okay, we've used supplementary angles, angle on a point, we've used parallel lines. Okay, so this is how you integrate maths in each other to solve your questions. Okay, thank you very much for watching today's video, and I'll see you in the next.